Right, so you do have another quiz if you go to the announcements here. And everything that's due is a couple places. One will be an announcement that kind of specifies that, and two will be under the assignments for this section. But quiz 3 again is due. Looks like next Tuesday. So you have next Tuesday another quiz due, and that is the graphing quiz. We talked about that one a little bit. I've got that one pulled up as well if you are interested. And it's really some basic graphing. The two graphing problems involve just graphing a cosine function and a negative sine function, looks like. So you probably would benefit you to figure out what the period is, what the amplitude, but I am looking for labels. So I want your x-axis labeled, I want your y-axis labeled, one full period. You don't have to extend it the whole graph or anything, but I do want at least one full period of each function. The last part is just giving me information about the graph. You don't have to actually graph it. I want to know the period, the amplitude, any horizontal or phase shift, or any vertical translation or any vertical shift of your graph. So that is due next Tuesday. So you got another week to kind of work on that. And that's kind of where we've been covering the last couple sections. Really been more focused on graphing and sine, cosine, and tangent, and some other graphs. We did quite a bit of the homework, looks like, last time for section 4.7, but if you have questions on that or 4.6 or any other section, let me know and we can go through that. So feel free to let me know, and we'll come into homework especially a little bit later. Finally, your chapter 4 test I do have available now, and it is due next Thursday, so that gives you about, from last night to next Thursday, about a week and a half to work on that. I kind of expect to be through with chapter 4 at the end of this week. So today we'll do 4.7. On Thursday we'll cover 4.8. And we'll probably go ahead and review for the test a little bit. And then next Tuesday we'll definitely have some more time to review and answer questions about the test, practice tests, things like that. So, but that is due next Thursday. Same kind of deal. I try to give you at least a week and a half, but at the same time I don't want to be teaching all kinds of new material that's not on the test at the same time you're still working on your test. So I tried, the timing there is a little hard to get down, but hopefully that'll be good. So at the end of this week you should pretty much have what you need to do the test. So it gives you a couple of days, and then we'll review, and we will start some chapter 5 stuff next week. Now, that being said, next Friday morning is when I will download homework scores. So 4.1 through 4.8, I will download all those homework scores next Friday, and you need to have a 50% or better on each individual section, or you will get -3 points on your test grade. Okay? I'm still going to download all the homework scores at the end of the semester, but this just kind of gives you an opportunity for bonus. If you get 100% on each of those sections, you get +5 points on your test grade. So I will download those scores next Friday morning. So make sure you're kind of keeping up with those homework sections if you want that bonus and want to not get deducted and things like that. So questions on any of that? Anything that's due? Quizzes, tests, homework? All right, no questions today. All right. That's okay with me, if it's okay with you. All right, so last time we talked about 4.6, we went through graphs of tangent and cotangent. Personally, I kind of think teaching graphing, especially when we can't do as much on paper, is kind of tricky. What I meant to do this class, and I forgot, was to provide you some printouts of just some blank graphs and just graph a couple things. Remind me, yeah, I'll try to remember to do that Thursday, because I would like to get you a little extra practice other than just the quiz, obviously, where we actually just come in and graph some things. So I'll try to set that up for Thursday. I'll give you some basic functions, and I'll walk around the room. You can try to graph. Make sure we're all on the same page. So. All right. So with no questions, I am going to start into section 4.7. Section 4.7 deals with inverse trigonometric functions. We've introduced this a little bit. If you remember correctly, we got to a situation in a couple chapters ago where we said, what if we have something like this? Sine of x, for example, equals, I don't know, say 0.58. How do you solve an equation like that? And we talked about that a little bit. We said essentially what you would do is you would take the inverse sine of both sides. So it would be the a sine button, or the sine to the -1 looks like power. When I do that, sine inverse of sine is x. So that gets rid of the sine part of that. So x then would be equal to the inverse sine of 0.58. And again, that is inverse sine, not 1 over sine. It usually looks like that. It could look like, on your calculator at least, could be this, a sine, which stands for arc sine, I think. So same difference. And the way we've been solving that, and I forgot I don't have a calculator, so give me a second here, is I come in here and say, all right, function inverse sine, there we go, of 0. Whatever I said, 58. And I would get 35.45. Now be careful, because this is in degree mode, I think. So it'd be 35.45 degrees would be the answer here. Or I'm perfectly fine with 0.62 radians, as long as I know that you're saying radians and not degrees, or vice versa. So if it's in particular, if it's a degrees, put a degree symbol. Okay, so we talked about that a little bit, just some very basic, if we have that situation, how to solve that and how to do that. This section goes into a little more detail as far as how these functions are defined. So for a function to be one-to-one and to have an inverse function, if you go back to kind of algebra talk, then it has to pass something called a horizontal line test, right? My horizontal line should not intercept the graph of my function at more than one point. Well, if you look at, actually let's do that. Go to my other calculator. If I have a sine function though, that doesn't work out so well, right? I can plot all kinds of lines. Let's say I have y equals 0.2. All right? I am intersecting this graph here, 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 all kinds of points, unlimited points really. So the sine function by itself, y equals sine of x with no constraints, is not one-to-one. It's not I cannot find an inverse function of sine of x as is. So in order to get around that, what we're going to do is we're going to limit the domain of that function, and do the same thing for cosine, the same thing for tangent. So if I take that y equals sine of x, and I say, all right, let's only look between, say, negative pi halves and pi halves. Well, now, if you look, the graph of this function looks a little bit different, right? Now there is no specific point where I'm going to intersect that graph at more than one spot. Okay, so that's okay. I can find the inverse of this function by limiting that domain. Okay, now if you remember correctly, the point for inverse functions, if I have a point a comma b on my function f of x, then that point b comma a, if I flip those, is on my inverse function. That's part of my inverse function. And also it's a reflection about the line y equals x, because if you go back to kind of algebra and how you find that, if I gave you a function 3x minus 1, and I said find the inverse function, then there's multiple ways to do this, but probably the first thing you would do is you would flip x and y. So, well, let's say x equals 3y minus 1, and then you would solve this new function for y, and that would give you an inverse function. And you could test that various ways, but really it involves flipping x and y, your domains and your ranges. So that's another way we can kind of look at inverse functions. Is in reality the inverse functions are the same as the regular functions, flipped around this line, y equals x. And let's change that a little bit. Let's make that dash. Let's make that a little smaller. I don't know. Okay, that looks a little better. So if I take that and I flip it around that line, then I'm going to get the inverse function, really. I'm not sure how this works on here, so we're going to see. Nope. So you can see that it's really just that flipped over that. And the other way, like we talked about, is I could take this point, for example, right? If I take this point, and let's make this. If I take this point, or this point, which is really negative pi halves, positive pi halves, so this is positive pi halves comma 1. If I flip those and make this point 1 comma 1.557, that is this point right here. So that's essentially, I'm just flipping x and y to get all these points from red to green here. Okay, so that sounds confusing, but in general what we're doing is we're going to take the sine function and we're going to restrict our domains between negative pi halves and pi halves. For a cosine function, right, so you can kind of see our cosine function kind of does this, and then it starts repeating. So we don't want the repeating part. We just want only this part from 1 down to negative 1 here. So we're going to restrict the domain of cosine between 0 and pi. If you go to a tangent function, it's kind of the same, similar to sine in that it repeats after I get between negative pi halves and pi halves, and then I just start repeating that. So I don't want this part. I want only the part between negative pi halves and pi halves. Okay. So, all that being said is we can now start thinking about how these inverse functions are going to work. Now, the other thing to keep in mind is if I look at a sine graph, let's just get rid of this for a second. My sine graph, you can see the y values of just sine of x are all between what? Just sine of x, no amplitudes, no a, b, d, all that. Okay. That's exactly right. They're between negative 1 and 1. So if I try to take the inverse sign of a number that's bigger than 1 or smaller than negative 1, you can't do it because there is no corresponding x value at which that will be true. So if you can try that. If I come in here to my function, and let's just say, see, I've got inverse sine of 0.58. That looks great. But if I try to take the inverse sine of, say, 1.2, it's going to be undefined, right? Because it's beyond those bounds. I can only find the inverse sine of a value between negative 1 and 1. And the result is going to give me an angle. And that angle is going to be between negative pi halves and pi halves, or negative 90 degrees and positive 90 degrees. So there's a lot of stuff in here and in the book that kind of describes how inverse functions are defined and how you can set those up and find those for sine and cosine. Here's kind of another picture. There's also an idea here with sine. Again, if I have 0, 1, that's on my cosine graph. If I flip those, 1, 0, that point is on my inverse cosine graph. If I take pi halves, 0, which is on my cosine function, and I flip those, 0, pi halves, that's on my inverse cosine function. Again, pi halves is about 1.57, something like that. And if you go to the graph, 0, pi halves, I'm going to switch that. Oh, I don't have that drawn on. I don't have the inverse cosine graph. Let's look at that real quick. I better make sure that's correct. So we said 0, 1.57, so 0, 1.57 pi halves is right there. So here's kind of the look at the inverse cosine in the cosine graph. And we're saying we want that to be between 0 and pi. So we're actually taking this red graph here again, and we're just flipping it around that line y equals x. Okay. And of course -1, so that gives me the point -1, 3.141592, etc. And you can see that's also on our graph. So different ways of getting these inverse functions. What it really leads down to is a couple things. Anytime you're asked the inverse sine of some value, or inverse cosine or inverse tangent, what I'm really looking for is what angle gives me a sine of, say, square root of 3 over 2. What angle gives me a tangent of whatever the value is, 0.537. So that's fine. So let's do that. Let's find the exact value of some of these, and that's, again, the question we're asking is what angle is going to give me this. So find the exact value of the inverse sine of the square root of 3 over 2. Now, there are various ways to do this. You can use your calculator, and that's okay with me. But for this session at least, we're going to try to do at least the first couple without a calculator. So I'm saying I have an inverse sine. I have some angle that gives me a sine of square root of 3 over 2. So for sine, again, if I look at the angles that are going to give me sine, it has to be somewhere between negative pi halves and pi halves. That's the way we have defined sine. So I have to figure out what angle that's going to be. So in this case, I have an angle of square root of 3 over 2. So in this fourth quadrant, then my value would be negative, right? So we said the sine is going to be negative down here. So it's not down here. My angle is not going to lie down here. It's not going to be between negative pi halves and 0. So I'm looking for some angle in this first quadrant at which my opposite side is going to have a length of square root of 3, and my hypotenuse is going to have a length of 2. Right? Using triangles. So if I use triangles, that's the case, and that angle should look somewhat familiar. You might recall, hey, my third side here, that's short side, and you can solve for that if you'd like, right? I could say, well, a squared plus square root of 3. Let's do that, actually. A squared plus square root of 3 squared equals 2 squared. So if I do that, I have a squared plus 3 equals 4. So I get a squared equals 1. So a equals 1. So that's my adjacent side. This angle is a 60-degree angle, if you remember correctly. So the inverse sine of a square root of 3 over 2 measure is going to be a 60-degree angle, or pi over 3 radians, okay, between negative pi halves and pi halves. Could you do this other way? Sure. I could see square root of 3 over 2, and I could come to section, what section was that? 4.6? No, 4.4 we had the unit circle. I could come in here and say, all right, I have to be either here or here, and I come in here and my sine is my y coordinate, and square root of 3 over 2. So it has to be this angle, pi over 3. Okay. So you can find those exact values. It's not super tricky. You can use your unit circle even. Oops. Wrong section. Okay, so let's do another one. Inverse sine of negative square root of 2 over 2. So I kind of do, like I said, I'm a triangle guy. I like to come in and look at these triangles. I'm going to go through a similar situation, but I'm going to know here it's not positive, right? This negative sign, it's not going to be here. And I already know it can't be here, it can't be here. It's not defined there. So inverse sine. And my opposite side, and then you kind of look at this, and this one's a little trickier. You say, oh, my opposite side would be square root of 2. Well, it could be. You could think of it that way. You may recall, though, that square root of 2 over 2 was the same as 1 over square root of 2, so you could look at it that way. But I don't know. Let's just do it as is. Let's just say, all right, my opposite side is going to be square root of 2. My adjacent, or my hypotenuse, is going to have a measure of 2. So I still don't know what A is, for example, here, right? Now this negative, I'm going to make that negative square root of 2 because my y-coordinate of that point would be negative. And that, you may already know what this angle is, so it's not super important to do this, but you could come in and say, all right, what's my other side here? Say, well, A squared plus negative square root of 2 squared would equal 2 squared. And that's okay. So I'd have A squared plus 2 equals 4. So I get A squared equals 2. So A would be equal to square root of 2. Okay. Well, that's kind of interesting, but this is kind of one of those too where you can come in and you could set up different values here. This is still a similar triangle to your 45 degree. So again, if you come to unit circle, I could come over here and say, well, all right, negative square root of 2 is my y value. Hey, it's right here, 7 pi over 4. Easy enough. Always do that. I'm not used to flipping around here. But all that being said, I know that this angle in standard position, inverse sine of negative square root of 2 over 2, is going to be 7 pi over 4. Or maybe you want to use your calculator. Maybe you come in here and say, I don't know, what is the inverse sine of negative square root to divided by 2. And I get this. Well, that's a little more confusing. That's one reason I say using your calculator can be a little questionable. But for degrees, hey, that's okay. Negative 45 degrees. And I'm okay with the negative 45 degrees, sort of. The problem is that's not really in standard position, right? I'm going to look for, and I'm going to specify that on your test. I'm going to look for an angle to be between 0 and 2 pi radians, and I'm looking for an angle between 0 and 360 degrees. So I would expect you to say, well, 7 pi over 4 is fine, but if I take this value, I want to say 360 minus that, which is what, 315? So the answers I'm looking for are either 315 degrees or 7 pi over 4 radians. Okay, any questions on that? Okay, so let's just keep going with this here. Find the exact value of the inverse cosine of negative 1/2 and inverse tangent of negative 1. So it's kind of a similar process. Cosine's a little bit different though, right? I'm going to come into my cosine graph and I'm saying, all right, it's going to be negative, and it's between 0 and pi is where that angle has to lie. It's positive over here, so I'm not going to be in that quadrant. So my adjacent side is going to be 1, or negative 1 in this case, and my hypotenuse is going to be 2. Okay, so you could find that other side. It ends up being square root of 3. And you might say, hey, that has a reference. The reference angle here, at least, is a 60-degree angle. Well, that's not my answer. But because that reference angle is 60 degrees, that means this angle from standard position would be 180 minus that 60 degrees. So I would get 120 degrees for the angle here, which is a 2 pi over 3 radian angle. Okay. So, or we could do what we did before. I'd come in here and say, all right, I'm looking between here, and I'm looking for my x value to be negative 1/2, and guess what? There it is. 2 pi over 3, 120 degrees. Okay. So what about inverse tangent? Well, it's kind of similar, except I still like to think about which quadrant I'm going to be in. Inverse tangent has to be between negative pi halves and pi halves. Well, it's positive up here, so it's not going to be up here. So it's opposite over adjacent. So my opposite side, at least, if I make that, say, -1, that makes this a 1. So what angle is that? Okay. We talked a little bit. This is, again, one of our kind of special angles we talked about. That hypotenuse is the square root of 2. The reference angle, at least, this angle here, theta prime, essentially, is a 45-degree angle, right, or a pi over 4. So what is theta? That's the real question. What is my angle? Does anybody know? It's another 315-degree angle, right? So theta, if this is a negative 45-degree angle, then to get around to there, to make that the rest of that 45 degrees, that theta has to be a 315-degree angle, or 7 pi over 4, 2 pi minus pi over 4. Okay. Now this one's a little trickier as far as unit circle goes, but it's still possible. If I come over here and say, all right, my x and y have to be equal, and they have to have opposite signs, essentially. And it has to be either down here or up here. So the only place where those are equal would be at pi over 4 or at 7 pi over 4. Okay? All right, so that's kind of in general how you can find these. Calculators are also going to be used, and we've already used them a little bit. So this is good practice for you, I think, if you have a calculator, to try to go ahead and find the value of the inverse cosine of 1/3. So if you have a calculator, some way of doing that, go for it. Tell me what you get. I'll see if I get the same thing. We potentially should have at least 2 answers. Anybody got an inverse cosine of 1/3?
70.53.
70.53. All right, I have one. Anybody else have something different? Does anybody know? I assume by 70.53 you're talking degrees, correct?
Yeah.
All right. Does anybody do it in radians? I don't know. Let's see what I get. Inverse cosine of 1/3. Inverse cosine 1/3. I get 70.53 degrees, or 1.23 radians. That's okay. It says up to 4 decimal places, so I'll do the 5288. But yeah, I don't usually ask for that many decimal places, but just to point out. So inverse tangent of negative 35.85. Now remember, when I'm saying inverse tangent and it's negative, I should get a value back between negative 90 and 0 degrees because it's negative.
Negative 88.4.
Negative 88.4. Degrees, I assume. You might get something different. Okay. Negative 88.4. Now, if I ask, so that's great, and I'll take that because I'm just asking you to plug it in your calculator here. What is that in standard position, though? So if I wanted something between 0 and 360, what would it be? You just add 360 to it. It's not that hard in this case.
271.6.
So 271.6 degrees. All right, what do you get when you do inverse sine of 3?
It says domain error.
There you go, right? You can't take the inverse sine because it's not between that -1 and 1 where sine is defined in y. So it's beyond the range. You cannot find that. Now, that brings up an interesting point because when we start looking at inverse functions, we'll have to kind of consider that. For inverse functions, and again, I mentioned this a little bit, f of f inverse of x should give you x. F inverse of f of x should give you x. This is one way that inverse one-to-one and inverse functions are defined. Is if I take the sine of the inverse sine of some value, I should get that same value, but you have to think about that a little bit. So when the outer function is the base, the rule applies for the range of that function. The outer function is the inverse, then you're just going to apply for the restricted domain. So in other words, if I try to take the sine of the sine inverse of x, that's only going to work if x is between -1 and 1, right? So my outer function is sine. I can only have a value between -1 and 1. So if this value x here is, say, -1.2, I can't just say that the sine of sine inverse of -1.2 is -1.2, because it's not necessarily. On the flip side of this, if I'm taking the inverse sine as the outer function, then my x has to be between -pi-halves and pi-halves for me to be able to say that this rule is going to hold. Okay? Now that's easy enough for some value. So if I come in here and I say the cosine of the inverse cosine of 0.7, I'm going to know immediately that that is 0.7 because 0.7 lies between -1 and 1, right? The outer function has to be between -1 and 1. But if I came in here and it was something different, maybe we have an issue. So let's actually look at some homework problems because this comes up in homework. And let's see, I said numbers 9 and 10. I don't know if that's still the case or not. One other thing, if you're working through these homework sections and they're taking you what seems like a very long time, let me know. I can get rid of some homework problems. We can adjust these homework sets. I think these kind of are what comes with my math lab. In the past, I've gone in and done that, starting in, especially in some of the other chapters. And some sections have a lot of problems, and some of them are really short and stuff like that. But if it seems like they're taking an inordinate amount of time, just let me know, and I can adjust those a little bit, at least, as needed. Because if I remember correctly, these got all reset to larger homework sets than what I used to have. So I can probably make those a little shorter. Now, I think as we get into Chapter 5 and 6, I've already adjusted those, but I'm not sure about Chapter 4. Okay, so find the correct value. So inverse cosine of 0.5, cosine of the inverse cosine of 0.5. So what do you think this is? One, is it undefined or does it exist? Say what? It exists, right? My outer function is cosine, so for this to be able to be 0.5, it has to be between -1 and 1, and it is in this case. What about this one? Inverse sine of the sine of 2 pi over 3. So for this to be true, what did we say? The outer function, inverse sine, is defined between -pi-halves and pi-halves, correct? This is bigger than pi-halves. Agreed? So if I come in here and say this is undefined, you would think that would be correct. It's not correct. Just because it's not equal to 2 pi over 3 doesn't mean the answer does not exist in this case, right? Because in this case, I can find the sine of 2 pi over 3. All right, I can plug that into a sine function and find that value. Let's do that, actually. What is the sine of 2 pi over 3? Well, this is good practice. It'll be a good practice test question. What's the sine of 2 pi over 3? might need your unit circle. You might not. You might want to draw a triangle. I'll draw a triangle. 2 pi over 3. That's over here, 60-degree reference angle. 1, -1, square root of 3, 2. So what's the sine of that angle? It is square root of 3 over 2. So what I'm really asking in this question, though, is the inverse sine of square root of 3 over 2. Does that exist? Sure. That is between -1 and 1. So yeah, I can find the inverse sine of square root of 3 over 2. Now, is it at an angle out? No, it's going to give me an angle between negative pi halves and pi halves. So I have to think about that a little bit. When I see inverse sine of square root of 3 over 2, I have to say, well, which quadrant? Right, it's going to be in the first quadrant because it's positive. My opposite side is going to have a square root of 3. My hypotenuse is going to be 2. 1. Now I already kind of know the reference angle here. That's going to be a 60-degree angle. So it ends up being 60 degrees, or in this case, pi over 3. So just because I don't fall within that constraint doesn't mean it's not going to exist necessarily. So in this case, it does exist, and it is the angle pi over 3. Maybe. It lets me put in pi. Okay. Okay. So inverse sine of the sine of 2 pi over 3 is not 2 pi over 3 as like this general inverse functions work. It is pi over 3. What about this one? Inverse tangent. Well, inverse tangent has to be between negative pi halves and pi halves. This is between negative pi halves and pi halves, so I should just be able to say pi over 6. What about this one? Okay, this is kind of the situation we had before. Inverse tangent, that angle is not between negative pi halves and pi halves, so I can't enter 2 pi over 3 will not work here. But I could do the same thing I did before with the sine function, maybe, and get a valid value, especially with tangent. If I do that, and I say, well, what's the tangent of 2 pi over 3? Well, the tangent of this angle, we would say, is negative square root of 3. So if negative square root of 3 is the tangent, and I'm saying the inverse tangent of negative square root of 3, well, I have to go through the same process, but I'm going to be not in this quadrant anymore because it's a negative value. So my opposite side is going to have a negative square root of 3. That makes my adjacent side 1. So you can come in. So this is triangles. If you want to use unit circle, you can. Like in this case where you got to square root of 3 over 2, you could have gone to your unit circle. But I know that this reference angle, at least, is 60 degrees. So the way inverse tangent is defined, I want my answer to be between negative pi halves and positive pi halves. So in this case, I'm going to use negative. Did it work? Oh, it worked that time. Pi thirds. Let's just try this. I think if you enter a value that's not between negative pi halves and pi halves, it's going to give you an error. But let's double check that. If I put that as 5 pi over 3, I think I get an error. Yep. So it's going to have to be negative pi over 3. Okay. Let's do one more. The sine of the inverse sine of 5 pi over 3. So for this to be true, for this to be 5 pi over 3, then 5 pi over 3 would have to be between negative 1 and 1, because sine's my outer function. Well, it's not. So it can't be 5 pi over 3. So then I get to the next question. Can I take the inverse sine of 5 pi over 3? I don't know. Can we? Let's try it. what angle will give me a value of 5 pi over 3? And it's going to be none, right? Because for me to take the inverse sine, it has to be between -1 and 1. So in this case, I can't even take the inner function. And just to point that out, maybe, inverse sine 5 pi over 3, undefined. So now my inner function is undefined, so I definitely can't take the outer function of an undefined value. Whereas before, we had 2 pi over 3, so we could do that. We could take that actually. So it kind of depends. You have to think about these a little bit. So in this case, though it is actually undefined. Okay, so this is the question I want to come to next. I like these questions because you got to think about these a little bit too. Okay, now, and we've done this to some extent. We can use points and triangles to find exact values of some of these inverse functions using composition function kind of techniques. In particular, if I ask you to find the sine of the tangent inverse of 3/4, this is a good example. Because one, you can come on your calculator and you'll get me a good decimal answer, but that's not what I'm looking for. I'm looking for an exact value. The key here is I am looking for a triangle here at which the tangent has a ratio of 3 to 4. Right? Opposite to adjacent is 3 to 4. What is the sine of the angle that would give me that situation? Okay. So I don't necessarily want the angle, I want the sine of the angle. So we have to think about that a little bit. Find the exact value of the sine of tangent inverse of 3/4. So the first question I'll ask you is, what quadrant will this lie in? Got 4 choices. Pick one. You guys are quiet. 2. All right. I'm going to disagree. Why would I disagree? Okay, so go to your function, tangent inverse. That has to be...
I was looking at the bottom one.
Oh, the bottom. Yeah. And you are... We'll get to that one. But inverse tangent is defined between negative pi halves and pi halves. So it has to either be in quadrant 1 or quadrant 4. Now it is a positive. When I take this inverse tangent, it is positive. So that inverse tangent is only defined in that first quadrant. So I'm going to come to my first quadrant, and I'm going to kind of sketch this out. My opposite side has a length of 3, and my adjacent side has a length of 4. Okay? So you're going to look at that and say, oh, what's my angle? Doesn't really matter. I just want to know the sine of the angle, and I want an exact value, so we're going to use this triangle to kind of figure that out. So using triangles, I could come in here and say, well, if my tangent is 3/4, this would be my hypotenuse. I'll call that C. Right? So I could come in and figure out what C is. I'm saying 3 squared plus 4 squared equals C squared. Well, that's 9 plus 16 equals C squared, or 25 equals C squared, or 5 equals C. So if that's the case, and this is 5, then what is the sine of that angle? Say what?
3/5.
It is 3/5. So on your test and stuff, that's what I'm looking for. I'm not looking for 0.6 even. I'm looking for 3/5. And I'll try not to give you one that's maybe that much of a gimme, but we'll see. So in this case, 3/5 is the sine of the inverse tangent of 3/4. Okay? So let's look at the next one. It says find the exact value of cosine of inverse sine of -1/2. So kind of the same situation. We got this inner function, it's the inverse sine, and I can only find the inverse sine is going to give me a value between negative pi halves and pi halves. So what quadrant do you think this angle is going to be in?
3.
Say what?
3.
Close. 1, 2, 3. It is in the fourth quadrant. Right? So that's this quadrant down here between negative pi halves and pi halves is going to be in this fourth quadrant. So I'm going to do the same thing. I'm come in here and say, all right, the inverse sine is negative 1 over 2. So that means my opposite side has a length of, say, 1. My hypotenuse has a length of 2. Okay, this one's a little more understandable at least. So I want to know not the angle, but I want to know the cosine of this angle. So to do that, I have to figure out what this other side is. Okay? So I'm going to come in and do something similar. I'm going to say a squared, in this case, plus negative 1 squared is going to equal 2 squared. Okay? So a squared plus 1 equals 4. A squared equals 3. So a equals square root of 3. Now, based on the position, that is a positive square root of 3. So then what's the cosine of that angle? So I'd come in, I'd say, well, it's going to be the adjacent side over the hypotenuse, so it'd be the square root of 3 over 2. And again, I am looking for that answer. I'm not looking for 1.86 or whatever you're going to get on your calculator if you try to solve it that way. And I believe the homework's going to say the same thing. So the cosine of the inverse sine of 4/5, if I come in and did that, this one's going to be this is one of those good triangles for us. So the inverse sine is 4/5, so that means the opposite side is 4. The hypotenuse is 5. I'm in the first quadrant. So I'd have a squared plus 4 squared equals 5 squared. So we'd get a squared plus 16 equals 25. So we get a squared equals, and I'm going through this fast, but a equals 3. So what's the cosine? Well, if a is 3, that's my adjacent side, 3/5. Type an integer or a simplified fraction. So if I put in 0.6, I think I'll get an error. Yep, simplified fraction. So they're doing the same thing as me. They're looking for that fraction in this case. Okay. This one, we'll do one more. So the secant of the inverse sine of negative 5/6. Ooh, this is a good one. I'll come over here. I've done a bunch of these already, but number 16. And negative 5/6. Okay, so first question, what quadrant? Where is inverse sine defined?
4.
It is going to be in 4, right? So sine, the inverse sine is defined between negative pi halves and pi halves. But it's positive up here, so it can't be in the first quadrant. So it's going to be in this other quadrant. So my opposite side has a length of, say, negative 5. Or really just 5, but we'll say negative 5. So we're in the right quadrant, right point here. And this would be 6. Okay. So it's kind of the same thing before. I need to figure out the length of this side. So I'll call that A here because that's kind of my adjacent side anyway. And I'll say a squared plus negative 5 squared equals 6 squared. So that's a squared plus 25 equals 36. So a squared equals 11. So I like this problem though, because guess what? A is equal to square root of 11. Okay. So getting the decimal value here is not going to do you a whole lot of good. You're probably not going to be able to figure that one out quite as easily. Now, I have seen some calculators actually give you the radical signs and all that. That's kind of neat. Okay, so it's wanting to know the secant, though. Well, what's secant? It's a reciprocal of what? Cosine. Right? So if I look at the cosine, I would say, well, the cosine of this would be square root of 11 over 6. So if the cosine is a negative or a square root of 11 over 6, then the secant is that flipped. So it'd be 6 over square root of 11. Well, that's still going to be wrong because I have a radical sign in the denominator, right? It's not a simplified fraction. It's not been rationalized, so I would need to come in and multiply the top and bottom by square root of 11. So that would give me 6 times the square root of 11 over 11. All right. And this one's kind of, oh, this is a good one. It uses symbolic. Oh, I don't know. Let's do one of these. Which one you want to do, 17 or 18? 17. All right. Good choice. Tangent of the inverse cosine of 2x. So this one, our answer is going to probably be something with symbols in there, with an x in there probably, so we don't have an exact value here. So we have to think about this one a little bit. It's kind of similar. It says assume x is positive. So that's helpful because that's going to tell us it's going to be in quadrant 1 between 0 and pi. So it is going to be in quadrant 1. And that being the case, my adjacent side I'm going to say is, I don't know, 2x. Over my hypotenuse, which is, I don't know, say 1. So that's interesting. It says, assume x is positive domain of the given inverse transform, simply including radicals. Okay. So we're going to come in here and say, all right, that's my opposite side. I'll call that b for now. And I would have 2x squared plus b squared has to equal 1 squared, right? Is everybody okay with that so far? Okay, just a triangle, setting it up just like we did the other problems. And by the way, that is quantity 2x. Oh, that would have been bad. So that whole 2x is being squared by the Pythagorean theorem. So when I square that, I get 4x squared plus b squared equals 1 squared. So, or just 1. I don't need to write squared anymore. So then I would subtract 4x squared from both sides. And you would get b squared equals 1 minus 4x squared. And then I would come in here and say, well, then b has to be, in this case, it is positive, so just be the square root of 1 minus 4x squared. Now, I can't take the square root of that. You can factor that, actually. It's two perfect square, difference of perfect squares. But it's not doing me a whole lot of good. So that's b. So I want to know the tangent of this stuff. So b is that, 1 square root of 1 minus 4x squared. So the tangent of that would be opposite over adjacent. So it would be the square root of 1 minus 4x squared divided by 2x. So let's make sure. Okay. That one's a little tricky. I like that question too. So like I said, I don't think all of these were on this homework set at one point. So if these are a little long, please let me know. This one's going to be very similar to the last one. You got a little fraction in there, but it's going to be the same deal. You're going to set up your angle. It's going to be in the first quadrant. I would say let your opposite side be 8. Let your hypotenuse be x. So in some ways, this one's a little bit easier because you can solve for that adjacent side a little bit easier, maybe. All right, graph the restricted secant function, 5 secant x. So between 0 and pi halves to pi. Well, that's okay. If I think about that, 5 secant of x, so that's kind of the, if you remember how secant works, it was the flip of cosine. So let's think about what 5 cosine of x would look like. Between 0 and pi. So for a cosine function, if you remember correctly, I can come down here. I come down here, and this isn't maybe not drawn to scale, obviously. But it's kind of like that. So my secant function itself would have this asymptote and this asymptote. So it would kind of be this. So the question is, it says between 0 and pi halves and pi halves and pi, and it wants me to graph the restricted secant function by okay. So in this case, it just wants me to graph the secant function. So that would be kind of this looking thing. So which one is that? Looks like B. Okay. Use the horizontal line test to say why the restricted secant function has an inverse function. So horizontal line test does not intersect this graph at more than one point at any place on here. So no horizontal line graph intersects the graph at more than once. So the function is one-to-one and has an inverse function, I believe. Nope. Oh, it does not. I'm sorry. No horizontal line intersects the graph more than once. The function has an inverse function. Whew. All right. So choose the correct graph below. It says, all right, use the graph of that to graph 5 inverse secant of x. So if I take that, and this would be kind of hard to picture perhaps. And again, if I go, and I want to flip it around that line y equals x, that's maybe a little hard to see. So let's do this instead. If I have this point, and this point, if you look at it, would be what? 0, 5. So if that 0, 5 is on the graph of secant, then 5, 0 would be on the graph of the inverse secant. So 5, 0 is not a point here. It's not a point here. Not a point here. And it's not a point here. So that's an issue. 5 secant, inverse secant. Well, I'm not sure. I would have thought that would be the case. So if I take that graph, though, and I flip it, that's going to come up here somewhere. going to look like that. And then this one, if I flip it around, the axis is going to look like. So it's going to have that general shape, looks like. I think the issue is this 0,5 is beyond this pi out here. That's why it's not showing up. Yeah, I'm not sure on this one. This is a. This one's kind of got me. This would be the point 0 or 1 0. Well, so see, that doesn't make sense to me. I don't think that's right. It could be. Nope. Oh well. Nope. Oh. Yeah.
Well, that'll give you a different problem.
It gives you a different problem after.
Do the view an example one. That one actually helps a lot more than help
Yeah,
solve.
that is true. I'm not sure, you know.
Because
it's
the
not-
view an example one has got me through a lot of stuff.
Yeah. So reflect about the line y equals x. So that kind of makes sense. So to see, that is the point. 0, comma, I don't know, 8. So 8, comma 0, way out here, should be on this graph, and it might be. It's just not on that domain, so we probably need to pick different points. So maybe we just need to pick different points. So 0, comma 8, so 8, comma 0 should be on our graph, but it might not be shown down here, right? Because it's only going to 5. I don't think it's showing it all to scale. So let's pick a different point. Let's say the point pi, comma -2. So -2, comma pi should be on our graph. So -2, comma, that looks like that's way bigger than pi. -2, that looks smaller than pi. Oh my goodness. Pi? Oh, that's pi halves, that's not 2. So that's 6, I guess, probably, yeah, 6.
Yeah.
So pi, comma -6. So -6, comma pi, it could be that one. It can't be this one, can't be this one. Doesn't look like it can be this one. It has to be this one, I think. Hopefully. Yeah.
You see, view an example always helps.
Yeah, that is true. So for this one, though, just be careful. I think the reason we couldn't take this point and plop it down here is because it's not part of the domain, right, of our next function, of the inverse function. So we had to take this one that is part of the domain and flip it over here, and it was part of our domain, so we're okay with that one. So just be careful which point you pick to flip, or you can look at it visually maybe. All right. So anyway, we've been through a lot on this section. This one, I love this question. It's very similar to the ones we've done. As far as setting up triangles, be careful because there is this 8 feet down here at the bottom you have to account for. So you really, if you think about this one, you have 2 triangles. I have the outer big triangle, which has a opposite side of 37 feet. And I've got this smaller triangle that has an opposite side of 8 feet. So you should be able to figure out X using some of that information. That's kind of a neat problem. We may come back and look at that one a little bit next time. Oh, that one looks like statistics. Okay, so this one, you're looking at the region of care between 2 and 3 there, approximately 6 square feet. So anyway, we'll come back to that next time. We're pretty much done with this section, but we'll come back and see if you have questions from homework. Let me take attendance real quick. Don't forget that your quiz is due tonight. So if you have not turned in that previous quiz, don't forget that is due tonight. And then next Tuesday's the graphing quiz, and your test is now available as well. All right, Cody. Tawo. Tawo? Okay. Leah. Thank you. Peter. Here. Kevin. Tyler. Thank you. Leslie's here. Brandon. Okay. Amos. Okay. Andrew. Lane. Hannah. Thank you. Jacob is here. Colton. Mike Schmidt. Okay. Sarah Schwab. Right here. Tim. Is Michael Schmidt here? Oh, I had that one wrong. Sorry. So you're Tim, right?
Yeah.
Okay. Robert. And Zach is here. All right. So unless there's any questions, I think that's it for today. I'll see you on Thursday.
So will the next chapter will be posted next week for all the notes and everything after chapter 5?
Yeah, probably. It'll be soon. I don't know if it'll be next week per se, but it'll be close.
Okay, because may or may not have fully gone over both chapters of the chapter.
Oh, okay.
So now we're just sitting here just twiddling our thumbs till the next.
Yeah, chapter 5 is usually the trickiest. The ones that get people the most issues. Chapter 6 is my favorite actually. So.
Yeah, that's what we're waiting on now. Just
Yeah.
chapter 6.
You tell me if I'm working
Yeah.
this right.
Oh, the bonus question. Okay,
You
so
could do it with it being the quiz.
so you're saying tangent theta is A over 348. I'm okay with that. And then you're saying, okay, so then you're saying 348 times tangent 50. I agree that the measure of A, all A there, is probably correct, assuming you took that tangent correct.
Okay.
Now, is that equivalent to the height of the roller coaster? I have to look at the problem.
What I'm wondering is do I need to adjust for the 6?
Oh, I forgot to do that in another quiz. Yeah, that's what I was going to say. You probably do. So, do you have the quiz itself? Let me see the picture again. So yeah, so you're finding. So when you're finding the tangent of that angle, you're not finding A. You're finding only that length, right? So you do need to add in that extra 6. Right? So based on this triangle, you've got 348 and you've got A, but you're not accounting for that extra 6 feet or whatever.
And did you see the email from Maria from me about me?
I did, and congratulations, I think. But you'll be out
Well, it's
at some point. I can't remember. I did kind of glance at it.
supposed to be now, but it's in case I'm late because we've got a
Okay.
meeting at 4.
Okay.
And I live an hour away.
Oh, wow. So is that here you're doing this?
Yeah, it's virtual.
Okay. Yeah. Cool.
So, and it goes through next Thursday.
Okay.
So I'll do my best to be here, but
You're fine. Do what you need to do, and
Okay.
congratulations. No,
Thank you.
no big deal. So that's cool. So do you like it so far? Yeah.
it's interesting.
Yeah. So it's out of
Uh,
Colorado.
Well, technically, today was at a JPL.
Okay. Okay. So
So-
different places.
Yeah.
That's kind of neat. I'd never heard of that till
I didn't either.
So.
So it's only for community college students too, so
Yeah.
that's what I like.
Huh. That's neat. Yeah, I'll have to read the detail, the email a little more detail, but it looked like it'd be a neat program, so that's good, get you a little, real world application kind of stuff.
That's what I like.
So, yeah. I'd say so. Well, congratulations, yeah.
Alright, can I have the PDF for the unit circle? And say like,
Yeah.
what site can you refer me to so that I can learn more about the whole thing?
Yeah.
Because, the thing is, I know about this stuff,
Uh-huh.
but it's been like about like 2-3 years since
Okay.
I've actually went back.
Yeah, if you go to,
Like, what's the name of the topic so that way I can look into Khan Academy?
yeah, that's what I was gonna say. So I've got the unit circle. If you just want like a copy of it under section 4.4.
Okay, section.
4.4, and it's just part of that handout at the very bottom.
All right.
Now, the other thing you could do, though, is you can just,
Type in unit circle.
yeah, that's fine. And you'll get all kinds of pictures, and I assume most of them are correct. No, that one's might not be, yeah, that one's not filled in, but you come to these and you can see various representations. I like this one because it's got the angle in radians and degrees.
Okay.
And it's got the measures. So that one's pretty good. The other thing I would recommend is, yeah, Khan Academy. If you go to, I thought I had a link for it. Huh, I don't. I have to add one. You know what? I'll do that. I'm thinking about it. You go to my last trig class. 'Cause I think I had it pointing to the actual
The topic.
topics. Yeah.
And also,
Trigonometry, so, yeah.
Okay, so based on the quiz, will I have to, like, do I just solve the triangle as an angle 90 right on, or?
Yeah, yeah, so it's just a right triangle essentially. I can't remember.
Because I keep on flipping it. I flipped it and solved it like that.
Yeah, and that's fine, as long as everything's consistent, right? I can't remember, let me,
Because
should I pull that up too?
the angle was about like right here. You had the angle right there.
Yeah,
And what I did was I flipped it and used the silver tool on it, like, you
Yeah.
know, the long side and the short side.
right. So this is your hypotenuse in this case, just so you know. This would be your adjacent side,
Oh, okay.
and this would be your opposite side of theta. So you can flip it if you want to, but you have to maintain that that's your, so now that's your opposite, and your theta's over here, adjacent. You can do that. I would just
I'll
leave
just
it
solve
like
it like
that.
that.
Yeah, and you're given two sides, so you're given the hypotenuse being 7, and you're given the opposite
So-
side being 3, so you just need to find that adjacent side.
So, real quick for sine,
Mm-hmm.
so since it's as opposite of adjacent, because the adjacent is I saw there's 2 square root 10.
Okay,
I saw there's 2 square root 10.
okay.
And so since it's sine, then that's gonna be opposite of our hypotenuse.
That's right.
That's 3/7.
Yep.
So I'll leave the answer like that.
Mhm. That's it.
And okay, so one threw me off, which came here, which is the tangent.
Mm-hmm.
So the tangent is opposite of our adjacent. That's 3/210.
Mm-hmm.
And I solved that. It came out as 6 square root 10 over over 210. That's no, because the 10 2 times 10
Okay.
at 20. So is that right?
Well, let's think about it. So to do that, what you do to get rid of this radical sign is you multiply by square root of 10. And that gets rid of it on the bottom, so that means I have to do the same thing on the top. So I think you're on the right track. I'll cross that out. So if I do that, I get 3 times the square root of 10. I know what you did actually. You probably did this, right?
Okay.
That's okay too. So I would get 6 times the square root of 10 over 2 times.
Oh, 2 times 2 is 4.
2 is 4 times 10, so it should be an over 40. But now I can divide, right? 2 goes into that 3 times. And goes into 40 2 times.
Okay. So.
Or if you wouldn't have done that, you just said only multiply by square root of 10, then I would have got 3 times the square root of 10 on the top and 2 times 10, 20 on the bottom. So you get the same answer either way. But you don't have to multiply by that 2, I guess.
Alright. So can I leave the answer like that? Once I
That's
solve
it, yeah. Once you've done that, that's your answer.
Okay, I don't have to put the fraction into it. Like decimal.
No, no decimals. Yep,
Alright.
that's correct.
And for the other part, the pi,
Yeah, I've got it pulled up over here.
yeah, this part.
Yeah.
Alright, so it says sine 3 pi over 4. So like the way I solved it, I think it came as I think square root 2 over 2 or something.
That sounds close. So really what you can do is if you've got it, if you actually find your unit circle, is you can come in here and say, all right, where's 3 pi over 4? And I can come up here and say, well, my cosine is my x value, so it should be negative square root of 2 over 2.
Oh, okay.
And the sine would be your
Square
y
root 2.
value, so it'd be positive square root of 2 over 2 in that case.
So wait, like I'm sorry. When you said the sign, okay, which quadrant is like the sign? And say like it's got the the unit circle. So which side is the sine, cosine, tan?
It's always this. The points on that unit circle are this one, cosine, comma, sine. So the x value is always your cosine, the y value is your sine. Your tangent is actually this over this. Y over x, if you're looking at those coordinates. So, like for that example, we have these coordinates, negative square root of 2 over 2, common square root of 2 over 2. Then the tangent of that would be the y coordinate, square root of 2 over 2, divided by negative square root of 2 over 2. So this over this is just 1, but there's that negative sign, so it just ends up negative 1.
Can I take a picture, please?
Yeah.
And it's been long since I've taken.
That's okay. I will add that link on here too. And available, submit.
And
I'll move that up.
when is the test due?
Next Thursday, so a week from Thursday.
Alright.
And I did add a link on here now, so if you click on that on Khan Academy,
Mhm.
it takes you to the trigonometry section.
Alright.
So here's like unit circle introduction. There's some of the stuff with the triangles and trigonometry, radians and all that kind of stuff, graphing. My trigonomic values, that's probably the one that has like that might help, would be my guess on that one.
So how can I still turn in the quiz 1? I wasn't in
Yes.
class the first day.
Yeah, that's fine. You do need to do that when you get a chance, because quiz 1 is due. I have already graded those, so I can't remember. I probably didn't get one.
Yeah, because I literally just figured that out. Like when you said something about quiz 1, I was like, I thought that was the first quiz.
Yeah, so if you go to the announcements,
Mhm.
there's still the announcement for quiz 1 online,
Alright.
and you can click on that, and it's listed, there's quiz 1, there's the PDF for it.
I can turn that.
And you can turn that in, or you can go under course content, I think, in chapter 4 and assignments. It's also under there. Quiz 1.
I can just, once I solve it, I can just take a picture and post
Yeah,
it.
that's fine. You should be able, if you click on, if you go into that shell and you take a picture, you should be able to go in here and then browse and attach it in here, and it'll show up in here.
Alright.
So, as an example, just to give you, so if I come in here and look, it actually brings it up for me, so I can come in and I can grade it in line and all that kind of stuff. So it's pretty easy to go in and do. So.
Oh, okay. Alright, thank you.
All right, you're welcome.